Today, let's look at the difference in size between our Earth and the Sun. Let's also talk about other things about the Sun in simple terms. Let's mainly consider the difference in size between the Sun and the Earth.
The Sun's size compared to Earth is an interesting and mind-boggling concept when you delve into the scales involved. From its sheer volume to its mass, and even its brightness, the Sun dwarfs our planet in almost every way. In this article, we will explore various aspects of the Sun's size in relation to Earth, discussing topics such as its mass, radius, volume, and the way the Sun compares to Earth in terms of energy output and influence on the solar system. To fully appreciate how much larger the Sun is compared to Earth, it's helpful to understand the scale of our universe and our solar system. The Sun is the most massive object in the solar system, containing more than 99.8% of its total mass. Without the Sun's gravitational pull, the Earth and every other planet would not remain in orbit. Yet, despite its dominance, the Sun's size often goes unnoticed in everyday life. This article aims to provide clarity on just how large the Sun is and how its size compares to Earth in various dimensions. One of the simplest ways to compare the sizes of two objects is by examining their radii. The radius is the distance from the center of an object to its outer edge. The Sun's radius is approximately 696,340 kilometers, while the Earth's radius is much smaller, around 6,371 kilometers. This means the Sun's radius is about 109 times greater than the Earth's radius. To put this into perspective, if Earth were the size of a small marble, about 1 inch or 2.5 centimeters in diameter, the Sun would be roughly the size of a large beach ball, about 3 feet, 91 centimeters in diameter. The volume of a sphere, which can be roughly calculated by including both the Earth and the Sun, is therefore roughly 1.3 million times the volume of the Earth. If you could fill the Sun with spheres the size of the Earth, you would be able to fit about 1.3 million Earths inside it. The Sun's mass is one of the most significant factors that defines its gravitational influence over the entire solar system. The Sun's mass is approximately 1.989 x 10^30 kilograms, whereas Earth's mass is around 5.972 x 10^24 kilograms. This means the Sun's mass is roughly 333,000 times greater than Earth's mass. To visualize this, consider that for every kilogram of Earth, the Sun has 333,000 kilograms. This huge difference in mass is why the Sun has such an immense gravitational pull. The force that the Sun exerts on Earth keeps our planet in orbit, preventing it from drifting away into space. Despite the Sun's enormous mass, its density is lower than that of Earth due to its much larger volume. The density of an object is calculated by dividing its mass by its volume. For Earth, the density is about 5.5 grams per cubic centimeter, GCM3, which is relatively high, indicating that Earth is composed mostly of dense, rocky materials. In contrast, the Sun's average density is much lower, approximately 1.41 GCM3. This is because the Sun is primarily composed of hydrogen and helium, which are much lighter elements than the metals and rocks that make up Earth. The Sun is largely gaseous and in a plasma state, so its material is less densely packed compared to Earth's solid structure. However, the Sun's central core is extremely dense and hot, with temperatures exceeding 15 million degrees Celsius, which facilitates nuclear fusion. The Sun's energy output is a crucial aspect of its size and its role in sustaining life on Earth. The Sun emits an enormous amount of energy, primarily in the form of light and heat. This energy, which is produced by nuclear fusion in the Sun's core, radiates outwards in all directions. The total energy output of the Sun is around 3.828 x 10^26 watts. This is an unfathomably large number, and it reflects the Sun's ability to release immense amounts of energy each second. In comparison, all of the energy used by human civilization on Earth annually amounts to only about 0.001% of the Sun's total output. The Sun's energy is what powers life on Earth and drives the Earth's climate system. The Sun's enormous size and mass give it significant gravitational pull, influencing every object in the solar system, from planets and moons to comets and asteroids. The Earth orbits the Sun at an average distance of about 150 million kilometers, 93 million miles. This distance defines the Earth's position in the habitable zone, where temperatures are just right to allow liquid water and sustain life. Without the Sun, Earth would be a frozen, lifeless rock drifting through space. The gravitational pull of the Sun keeps Earth and the other planets in orbit, preventing them from floating away into space. Additionally, the Sun's light provides the energy required for photosynthesis, which supports nearly all life on Earth. The Sun also plays a significant role in shaping space weather, such as solar winds and solar flares, which can impact communication systems and satellites on Earth. The Sun's magnetic field and its activity also drive phenomena like the auroras, the northern and southern lights. The Sun's surface, known as the photosphere, is not a solid surface like Earth's. Instead, it is a layer of gas, and its outer boundary is where the Sun's light becomes visible. The temperature of the photosphere is approximately 500 degrees Celsius, 9,932 degrees Fahrenheit. If we were to compare the surface area of the Sun to that of Earth, we find that the surface area of the Sun is roughly 12,000 times larger than Earth's surface area. Given that Earth's surface area is about 510 million square kilometers, the Sun's surface area is roughly 6.1 x 10⁻⁹ kilometers. This immense surface area results in the Sun being capable of emitting an enormous amount of radiation, and it also reflects the sheer scale of the Sun in comparison to Earth. The Sun is about 4.6 billion years old and is currently in the main sequence phase of its life cycle. During this phase, it fuses hydrogen into helium in its core, producing energy that sustains its size and supports life on Earth. The Sun is expected to remain in this stable phase for about another 5 billion years. As the Sun ages, it will eventually exhaust its hydrogen fuel. When this happens, it will expand into a red giant phase, likely swallowing Mercury, Venus, and potentially Earth. After shedding its outer layers, the Sun will eventually become a white dwarf, a dense remnant that will cool and fade over billions of years. However, at that point, the Earth will no longer be habitable due to the changes in the Sun's size and energy output. The Sun's size compared to Earth highlights the vastness of our solar system and the immense scale of celestial bodies. While Earth may feel large to us, the Sun is so much bigger that it is almost impossible to truly comprehend its size. From its mass and radius to its energy output and influence, the Sun is the central force that drives the dynamics of our solar system and sustains life on Earth. Without the Sun, our planet would be a cold, dark, and lifeless rock, emphasizing just how vital the Sun is to our existence. In conclusion, the Sun is a remarkable, awe-inspiring object that dwarfs Earth in nearly every way. Its sheer size and mass are awe-inspiring, and the energy it produces is fundamental to life on Earth. The Sun remains the most important celestial body in our solar system, and its influence will continue for billions of years to come.